Today we're going to be working on topic 2.8, the product rule. So we're going to learn how do you differentiate using the product rule, and I can differentiate using the product rule. So you'll note it with the last few videos we were talking about adding and subtracting. So those rules were pretty simple and straightforward. But this one, the product rule, and what we're going to learn in the next lesson, the quotient rule, are handled a little bit differently, actually quite a bit differently when differentiating. So the first thing, you have the product rule if you ever see the word times, or you say the word times, in a problem you're differentiating, you must use the product rule. So if you don't have the colors red and green, get the colors red and green. So we're going to use lots of colors. I think I'm going to use blue and yellow throughout the lesson. So colored pencils, crayons, markers, something. Pens. The product rule of two differentiable functions f and g is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second, plus the second function times the derivative of the first. So we're going to do, I'm going to underline these and color code them a little bit. So we're going to call our first function is going to be red. So we take the derivative of our first function. Our second function is going to be green. So we're going to take, and then we're going to multiply that by the original of the first of the green function. Then I'm going to keep the red function the way it is, and then multiply that by the derivative of the green function. So that way I know I've got a pattern red, green, red, green. We can do it in opposite order, which is what this is showing, but we're going to stick with this order right here for our purposes. So let's take a look at a few of these, or one of these at least. All right, so I notice I have 3x minus 2x squared times 5 plus 4x. So I am going to use my product rule because I had times. This is my first one here is the red function. My second one's the green function. I automatically just go ahead and underline that. And then I'm going to do h prime of x equals. I am going to do the derivative of just the red function. So the derivative of 3x is 3. The derivative of negative 2x squared is negative 4x. And then I'm going to keep my green function the way it is. So I'm not taking the derivative of it. And then I am adding that. The operation is always add. And then I'm going to keep the red function the way it is. So 3x minus 2x squared. I'm going to take the derivative of my green function. The derivative of 5 would be 0. The derivative of 4x would be 4. I am going to go ahead and simplify it. It depends on the problem. You may or may not have to actually do that. So in this first term, I'm going to FOIL. So I've got 3 times 5 is 15. 3 times 4x would be 12x. Negative 4x times 5 would be negative 20x, and negative 4x times 4x is negative 16x squared. I'm going to distribute the 4, which would give me 12x minus 8x squared. We're going to combine our like terms. I choose to put my x squareds up front, so negative 16 and negative 8x is negative 24x squared. 12x minus 20x plus 12x would be positive 4x. And then the only guy left is 15, so plus 15 at the end. So the question is, do we have to use the product rule for example 1? What else could we have done to find h prime of x? So in this case, I was trying to use a polynomial example, so you could do it with a polynomial first. In this case, we could have FOILed first. So the answer is no. We could have FOILed first and then taken derivative using the power rule. With power rule.